this way, some of it, I got some of it from ChatGPT, so I feel it will help us. First of all, what is Kubernetes itself? Kubernetes itself is a tool for managing containerized application. The keyword here is containerized. If your application is not containerized, Kubernetes cannot manage it for you. So the containerization itself is a keyword. You have to containerize your app before you can use the Kubernetes. What does Kubernetes help us to do? It helps us to deploy, scale, and maintain these apps. So whatever your app is, your app, either it is a front end, back end, database, or serverless, you can actually package it and containerize it, then deploy it on Kubernetes. So one of the abilities of Kubernetes is deploying, scaling, and managing those apps. So Kubernetes itself is works with containers created using Docker. So we are going to check the architecture of Kubernetes, and the simplest way is like they're explaining what a Kubernetes is in the smallest way, which is an illustration. It's like a running factory. You only have a small shop, you don't need a factory. Okay, let's ignore this one. Let's go to why Kubernetes exists. Why did they think about Kubernetes? Kubernetes was actually thought of because why? Containers can crash. That is when you are using, I don't know if you guys are familiar with what they call Docker Compose or stuff. So when containers crash, it cannot heal itself. It doesn't have auto-healing ability. So whenever a containers, we are looking at these two sides. This is why Kubernetes exists and key features of Kubernetes. So containers in the past, when container crash, there's no way it will restart this, it will heal or a new container will come up. So Kubernetes has a unique feature which is called auto-healing. It restarts failed containers. Another one is how to scale up. In Kubernetes, you can scale up because you can scale it based on traffic. Another this thing is difficult to manage many containers. When in the past, it was very difficult to manage many containers, but right now, you can manage as much containers as possible. If you have up to 50 microservices, you can manage it. And you can also manage traffic itself using load balancing. Because the load balancer, making the traffic is coming, you can actually direct half of it to a certain container, another half to another container. One other good feature of Kubernetes is rolling updates. No downtime during deployment. That whatever new features you want to incorporate is very easy. You don't need to pause a server. You don't need to worry about a lot of things. You just need to. There are different type of deployment type on Kubernetes. We have the canaries, we have the blue green, we have the A/B testing, and so on. So those are features of Kubernetes. Why do we use Kubernetes? We use them to handle large scale applications. When your application is not large, it is not advisable to use Kubernetes. You are just running extra costs. I don't know if I get if I'm communicating.
Yeah, you're communicating those.
Okay, so if your application is large, you don't need Kubernetes for it. You can just use Docker Compose, or you probably use the virtual machine and deploy your application there. Kubernetes is mostly used for large applications when you know that we have maybe like 20 or 30 microservices, then you use Kubernetes. Another reason why you use Kubernetes is it ensures high availability. Kubernetes will make sure that your apps are available at all times. Another one is it reduces manual work, because one of the good ability Kubernetes has is ability to automate. You just need to automate your deployment, like the CI/CD, you incorporate it with the Kubernetes, and your deployment is fine and good. It works across environments on different type of cloud. You have the Amazon website. When I talked about EKS, it work on Azure, which is AKS, and it work on Google Cloud, which is GKE. Then the on-premise Azure, the on-premise Kubernetes, which I told you about, is Rancher. Then we have hybrid. I think a hybrid Kubernetes example is this one that belongs to OpenShift. Yeah, OpenShift Kubernetes. Yeah, it belongs to Red Hat. I'm sorry. Why not? Why not use Kubernetes? Why not use Kubernetes? It means reason why some people don't use Kubernetes. The people that use Kubernetes, if you look at it, they are large firms. They are firms that have probably you don't expect YouTube that has over 200 million users not to use Kubernetes, because why? Their numbers of users is not the same number of users. Maybe a small leading app we get. YouTube is a large company, so they will always make use of Kubernetes. Big banks will make use of Kubernetes because they have a high number of people and they cannot afford their system to be down. Because one of the selling point of bank is high availability. The information has to be available at all times. So Kubernetes is a must in those kind of environment. But when the environment is small, you don't need Kubernetes. When not why some people don't use Kubernetes is why, one, it is complex to learn. The second one is overkill for small projects. If you are running maybe a e-commerce application now, you just have only 5 microservices. Using suggesting Kubernetes to the CTO is looking, you're already, I don't know the word you're using, but we'll call it asheju. You're already doing too much. So you at that point, you probably Kubernetes will not really help you to do that. The next one is it is expensive in the cloud. As you know, you can for Kubernetes on AWS, I'm very familiar about that. It's not free, and in other platforms too, it's not free because they will help you to those are managed Kubernetes services. Then it require cluster management because each this thing, each your cluster on Kubernetes is like a folder. So it's like a folder where different teams own different folder. Like Kubernetes, one good thing about Kubernetes is it encourages what do you call the word, collaborative environment, because you can also have a developer that has a cluster on his own, where all this one is just for developers. Those are the cluster. When they log in and everything, they will do their work. There will be no clashing between developer and people that are testing. We can have another namespace for people that are testing. Then we have another cluster for people that are in charge of production. Whenever your application is being tested, it will be pushed into production. So all of this, if you don't have somebody that has a good knowledge of it, it is reason why some CTO will not want to go for Kubernetes. Now we have Kubernetes deployment types. We have the on-premises Kubernetes, which runs which you run the server and everything on your own. Your control plane, your worker node, you run it on your own. Another type of Kubernetes we have is the cloud, Amazon EKS and AKS. I think I've said about it. And hybrid Kubernetes. One of the reasons why people use hybrid Kubernetes is because of flexibility, better for sensitive data, and disaster recovery. Yeah, because some people are very particular about information of their clients, so they will prefer them using hybrid Kubernetes. So what are alternatives for Kubernetes? Every time Kubernetes should not be your major go-to. It should not be your major go-to. Some of the alternatives to Kubernetes is Docker only, single server, virtual private server. And we have some host of companies that offers it. DigitalOcean, Linode, where you can host your application. Then another alternative for Kubernetes is Docker Compose. Docker Compose, you can use it to run multiple services, app and database. Then another one is PaaS, which is platform as a service. Some are like Heroku, Render. All you just need to do is push your code and everything is fine. So all those ones are alternative to Kubernetes. When you know that your services are not that much, then you use that one. When to use Kubernetes now, we have large applications. You should use, when you know that you have over like 50 applications, yes, use Kubernetes. Microservices architectures, when your different parts when your different services are in different things, you should use Kubernetes. High traffic system, when you know that you can't afford to trade high availability for downtime. Another one is production environment. Then you use Kubernetes. Avoid Kubernetes for small projects, beginner projects, learning stage. You should avoid Kubernetes. What is used in production instead of Kubernetes? What is used in production instead of Kubernetes? It depends on what they mean in this place is that what are things that are required before you, what are things that are required in production that depends why they use Kubernetes. First is the app size, the application size, the team size. Maybe we have the developer, we have the tester, we have the other teams too. So you should use Kubernetes. The traffic, when the traffic is high, you should use Kubernetes. So these ones are all these ones here are repetition. What are the types of application we have that can run on Kubernetes? The first one is web application, when we have a front end and a back end app, which example is e-commerce website, social media, and SaaS dashboard. You should use Kubernetes. When you want to deploy API, backend services, you should use Kubernetes. Services like API, such as payment API, authentication service, use Kubernetes. Microservices application, maybe you have one application, one application for logging, another one for payments. Kubernetes is perfect for microservices architecture because everything is in different parts. When you have a data processing and batch job, you should use Kubernetes. Another one is AI and machine learning apps. Kubernetes should be used. When you want to scale GPU and CPU workload or manage every workload, you should use Kubernetes. Another one is real-time application. Maybe you are deploying things like Facebook, chatting app, live streaming app. Kubernetes ensures that there's low downtime and load balancing. Another one is database. Many companies prefer manage database instead. So you can also you can use Kubernetes for it. But if you are doing microservices architecture, you can actually deploy your front end and back end and use maybe an external database. It all depends on how you want to do it. Some real companies that use Kubernetes, we have Netflix, they use it in streaming their platform. Spotify, they use it for music app. Airbnb booking platform. Uber also make use of Kubernetes. So that is all. Before I move into architecture, does anyone want me to say something? Does anyone have a question?
Now for me.
Sorry, I didn't get that.
I said none for me.
Okay. Should I move on?
Please do.
Okay. Now this Kubernetes architecture. In the last class, we talked about the Kubernetes architecture. Uh, we have we have two parts of Kubernetes architecture. We have the control plane and the worker node. So I'm going to show you a picture where I probably save a good picture of this. I don't know. Can you see my screen?
Yeah, we can see your screen.
Yeah. So this picture, I like it better than where is this? I can't put it side by side. Anyway, let me use the picture. Okay. So the Kubernetes architecture, we have two sides of Kubernetes architecture. This upper side is the control plane, and this one below here, they are the worker node. The control plane, which is the master plane, it contains four components, and one of those components are the API server, the scheduler, the control manager, the etcd. So whenever you actually write a YAML or manifest file, the YAML manifest file you write is going directly to the API server. So what is the API server? The API server is a server that uses REST API to, is like the brain of the computer. It uses REST API to communicate with every other part of the Kubernetes architecture itself. If you want to create a pod or any Kubernetes object, you write it and you click whatever kubectl apply the manifest file name. It communicates directly with the API server. The API server is what it communicates with. So the API server is like the brain, is one that decides how everything works. Another component in the control plane is the etcd. This etcd is the storage of this API server. Everything this API server is doing, it doesn't keep record of it. This is the database for the API server. So all of the information that's coming here, all of the activities this guy is doing, it is being stored by this etcd guy. So when this etc guy is missing, this one has already forgotten what he did. So it's as useless. So you are giving it another prompt. Together they work together, the API server and the etcd. Another component we have here is scheduler. The scheduler work is to schedule whatever pod to different worker node. All of these are the worker node. This worker node 1, this worker node 2, this worker node 3. So the scheduler has it will read the YAML file based on whatever you set, because you can actually decide which worker node you want your architecture to, your pod to probably fall on. You can define it in your YAML file. So the scheduler will be the one to read it and say, okay, this worker node 1 is very busy, it's not available. I'll put your container, I'll put it over here. This place is available. Or maybe you put a specification, maybe a what do you call it, resource quota, or CPU, you put maybe 500, you put 500 MB for your CPU request. This one does not have up to 500. then it's going to look at, okay, which of these worker node has this availability. So the scheduler does that. Another one is the controller manager. The controller manager is the one that watches over your pod and your container. Maybe you do a replica of 4 or 5, then something happen and the replica reduced to 3. The controller watches it and makes sure that that same number of replicas you want, maybe you want 4 pods running at the same time. It is the controller manager, the kube controller manager, that will decide that, okay, we need to replace this one that is down. Another one is cloud controller manager. That one helps you to handle your activities that is in the cloud. So that's everything on the master plane. Then on the worker node now, the worker node now has its own components. These are the worker node components. The kubelets, the kubeproxy. Then if you can notice here, this is a deep blue box. Everything inside this box here is Docker, which is container D. Then we now have a white box here where our pod actually lies. So when a scheduler schedules a particular pod, the first thing is first going to talk to the kubelet. The kubelet is the agent that runs everything inside this your worker node. So whenever this agent gets this thing, you'll be the one to, okay, you'll be the one to be in charge and communicate with the kubelet and the Docker, the container runtime. They will communicate with each other. So they'll be the one to make sure that your pod are available and they are running. Why the one that does anything networking for your pod, giving your pod IP addresses, is the kubeproxy itself. The kubeproxy is in charge of distributing the IP addresses for it. Why the container runtime, use your Docker, is the one in charge, because without this Docker, your pod cannot run. So the pod and the Docker, they work together in worker node. I don't know if there's a question you want me to say. If there's a question you want to ask. Mr. Daniel, I greet you, sir.
Hi, instructor. I'm on board.
So, sir, I don't know if we've kind of clarified things we discussed the last time on Monday.
The week I've been very busy.
Okay.
It's weekend. I'll go through, yes.
All right. No problem. Is there anybody there that has a question you want me to talk on? Should I move on?
Yes, move on.
Okay. Container. So these aspects here, we've explained the Kube API server, the etcd and everything. So we'll go to the next one. Yeah, this one is talking about the same thing. The control plane, if you have time, you can go and read it, which the most important thing is that it saves information or it saves information or recordings about the API server. Then the kube scheduler, it helps to schedule stuff. So the kube scheduler itself, it works, the way it does the scheduling is based on 2 attributes. The 2 attributes are filtering and scoring. In the filtering state, in the filtering phase, the scheduler eliminates all nodes that cannot accommodate the pod. That's when I said something like, it's going to check all of this worker node is going to check which one has which one is more suitable for this workload you want to deploy. So it's the one that's going to think about it and say, okay, this workload is okay. And some of the things you put into consideration in doing that is you check if the CPU is sufficient enough or the memory is sufficient. Another thing it does is you check mismatch node selectors. You check, okay, because in your pod, there's where you can actually identify that, okay, this when you write your apps, you write your selector, you specify app, then column, and maybe you say this is a front-end application. So for the front end, you can host all of them on the particular worker node. So it's going to check that, okay, which node does this person wants me to put this thing? If there's anything like label no selector, if you don't identify it, it picks something on its own. Another one is what they call taints and toleration. Taints and toleration is another attribute it uses in picking a node. What does taint mean? What does toleration mean? Taint and toleration means that when you tolerate something, that means you're allowing it to be with you or to come into your space. Taint means you use toleration for pod, you use taint for node. I don't know if I should come again. You use taint for node. You can assume, where is it? You can assume that this node, if it does not have any selector, like if the pod they want to schedule on this worker node, if it does not have anything like maybe your app is equal to backend, so automatically the scheduler is checking that does any one of these worker node has a taint indicated in them, because you can taint this worker node that say this one, the only pod you should accept is a pod that is labeled front end, that is labeled backend. If it's not labeled backend, do not accept it. So you will look at it and say, this guy he has been blacklisted for only backend. So he's not going to think about this guy, he's going to think about these other guys. So the process of doing that is you are tainting this node. You've labeled this node as just for backend only. While toleration means you are applying it to the pod. You are telling the pod that you are only going to a node that is only applicable to front end. You don't go to any other node except it goes to front end. So that's what the scheduler will do. Is to follow your instruction as you put it there. So there's what they call affinity and anti-affinity rules. Affinity and anti-affinity rules is from the word affinity, and affinity is means to attract, it means to draw. While anti-affinity means the opposite of what affinity means, which it means to push away. What does it mean in Kubernetes term? It means that your pod should be, affinity means you want your pod to cluster around a particular node. It depends on the type of specific workload. Anti-affinity means you don't want your pod to cluster or be in one location. You want them to be on different worker node. And why do you use anti-affinity rules? You use anti-affinity rules because you want high availability. If this worker node peradventure is down, because you have implemented a rule called anti-affinity rule, it will send some, maybe you do a pod replica of 4. It can give this one 2, give this one 1, give this one 1. If this one is down, this remaining 2 will still be working, because you've actually spread your pod in different worker node. So there's nothing like one, if one is down, the other will not move. Another this thing, so only the node that satisfy all these criteria is actually being picked into the next phase. Another phase that is that people know is called the scoring phase. The scoring phase is when the scheduler is ranking the node based on is when the scheduler ranks the many node to determine the optimal placement. So the scoring phase actually is going to score the nodes that are qualified based on their CPU usage, based on the node that are in the same zone, the volume and stuff. So I don't know how is allocative points for them, but it's going to allocate points for them, and the one with the highest score will be the one that probably gets your pod. I don't know if you get the point. So the next one is Kube Controller Manager. Kube Controller Manager. What does Kube Controller Manager does? Like I said the other time, Kube Controller Manager helps to monitor your actual state and your desired state. Maybe you identify that you want 4 pods to be running. The Kube Controller actually is the one that ensures that things are going as planned or as instructed. So that's what the work of the Kube Controller does. The worker node components, I think we discussed about it. The container runtime, the kubelets, the kubeproxy. Kubernetes setup now. We have different type of Kubernetes setup. This setup, this Minikube kind and micro K8s, they are just one clusters. That means you just have one cluster, maybe one control plane, or maybe one worker node. Those are all these Minikube kind and this thing, they are for development purpose or for testing or for learning stage. They are not actually production Kubernetes. Example of a production grade Kubernetes cluster is kubeadm, corpse, and kubespray. Those are the ones that are used by industry, the one like I mentioned, the Netflix, the streaming and stuff. Another Kubernetes vendor that is popular are Rancher. Another Kubernetes DC that is popular is called Rancher, K3S, Red Hat OpenShift, VMware Tanzu platform. Then we have the one of the Google Cloud. Then this is a demo. So we should do one demo of Kubernetes. Let me on my Docker. Is it? Docker. Let me use this place. Okay. Which Kubernetes is in? Let me start with. Okay, so this is the first Kubernetes this we run tonight. This is a simple pod deployment. What is pod? Pod is the smallest Kubernetes, is the smallest deployable unit in the Kubernetes object. So this is a YAML file. We're going the YAML file. What does a YAML file contains? A YAML file contains a API version, which is what what the Kubernetes API server recognizes is this API version. It wants to know that okay, this API version is referring to pod. That's how that's how it knows that okay, you want to create a pod. So the version name is v1. Then we have another one, we have another component, what is called kind, which is which type of Kubernetes object are you creating? Are you creating a pod? Are you creating a deployment? Are you creating a cron job? Are you creating a stateful set or something? So that's where you are going to identify which one which one you are creating. Then the metadata. What does metadata means? Metadata means the name of the pod. You're kind of labeling the pod itself, the information about that pod, so that you yourself will be able to identify it. So this name of this one is Nginx demo pod, then the label is this. Then this spec, you are talking about the information of your pod, of your container itself. That is what spec is. So the spec contains the container name, the image, the port, and the container port itself. So if you have time, you can actually go through this yourself. Then we'll let's create this pod. Then this is our this thing. Because of time, I'm just going to be copy pasting so you can just see it. If you have time on your own, you should try it. I see somebody drop a link where you can actually use an online server to run your this thing. So creating about pod, applying the manifest file that we copied here. You can, there's different way how people do it. You can directly just create pod, or you just do apply plot. Anyone that's is okay. The only issue, the only difference between this create and using apply pod directly is that when you use create, if your YAML file is wrong or incorrect, it will tell you immediately. It's just like, I don't know, those ones that are familiar with Terraform, when you do Terraform plan before you do the apply itself, it will tell you if your maybe you have syntax issue or something, it will be the one to tell you. So the normal convention is to create before you apply, but if you decide to ignore it, oh, I've not started my Minikube. Minikube starts. Where do I even put it? Minikube starts. I don't like to put. Yeah, this is what I'm looking for. It's laptop charging. So now our Minikube is already up. Let's first do kubectl get node. You can see here now, Minikube has only one.
You're not seeing your
cluster. You're not seeing my screen?
Yes, it's the hammer we're seeing.
Oh, let me do it again. Can you see it now?
Yes, we can see it.
Okay. So I set up my Minikube. I started my Minikube. I created my manifest file. Let me show the manifest file. This is a manifest file, just a simple pod. we are trying to deploy a container, which is an Nginx container. So this is it. Then, since this is Minikube, the node here is just one. If it was a bigger Kubernetes or production one, you have the control plane, you have the worker node. Then you are not advised to do anything on your control plane. You are advised to work on the worker node. So after that, after creating your YAML file, you will have to do creates. Let me pick this thing here. You have to do creates. You create whatever YAML file you did the same. So if your YAML file has an issue, maybe a syntax issue where you are supposed to give gap, you didn't give gap, it will notify you with create. Then the next thing is for you to do is apply the pod.
I'm not sure I can see your terminal where you're typing.
You can see my terminal.
It's just the browser we're seeing. Probably you shared only the window. Am I the only one?
Let me try it again. I had to share the whole screen, Abby.
Maybe share a window. Yeah, the entire screen. Okay.
Can you see it now?
Better.
So I've created the pod, I've applied it. So we will now do kubectl get pod to see if actually we've created the pod. Oh, it was unable to pull the image. This is an error. That means the image we're not able to pull that image. So let me check my YAML file. I think I have one Nginx image here I can use. Tokai image. Let me use that one. I don't know. Nginx. There's one Nginx image I can use here. Okay. Nginx 120. So let me go to this place. Pick this image. Okay. So we create and we apply it again. I don't want to but Nginx pod already exists. Okay, let me change that name. Let's change the name to pod 2. That pod is bad. Let's create kubectl get pod. Get pod. Let's see if the pod is up. So we can delete this one. This is you can see that now it is running now. So there's 5 pod life cycle. The first pod life cycle is what is that first one? Before this I can't remember this thing, but the first one you have 4 pod life cycle. Let me check ChatGPT first. I know the second one is running, and the third one is success, the fourth one is failure, and the fifth one is unknown. Pod life cycle. Yeah, the first one is pending, the second one is running, then the third one is succeed, and the fourth one is failure. So first of all is pending. But this one now, this is every time you try to deploy a pod and you get this error message, this image pull back off. What does it mean? It means that the kubelet could not pull your container image that you are trying to deploy. So either your container image name is wrong, or the tagging is wrong, or you didn't put the right container distance. So you need to go to your manifest file and go and rewrite it. So right now we're going to delete this guy. Put it here, delete this pod. The server doesn't have a resource type engine is demo. Really? But this is a bad pod. So let's just leave that one alone. Let's check what I think that's what the first demo is about. Let's see what they did in the okay, this one is installation of the mini cube and everything. So that is done. The API server. Now, this is an important matter in Kubernetes. The the API server, as we know, it is where it is like the entry point to your Kubernetes itself. Everything you are doing is passing through the Kubernetes API server. So we need to be security conscious in the fact that in terms of authentication, authorization, and admission control. Those three parts are important because you cannot just let anybody or any stranger have access to your Kubernetes API server, because him having access means he has control to do whatever. So that's when we need to implement authentication. Only people that are authenticated can have access to the API server. And how do we do authentication? We do authentication by giving your workload what they call service accounts, which is like a user. You're not giving him full access, you are giving him just a service account that whenever that service, you are giving example of a service account is, let me show, I think I have a YAML file that has a service account here. Do I have? I don't have example of a YAML file that has the service account, but service account is you're not is like a user, a particular user for a particular namespace. If it's not that user, the Kube API server will deny it. While authorization is to confirm, is to use what they call role-based access control. You are defining permission for each users and each account on what they do. You are not giving them the full access. While admission control, this one is the final stage before your request can get started in the control plane. If all of this passes, the authentication pass, the authorization pass, but this admission control fail, then you will not get access to the etcd or the scheduler. So nothing will work. So these three are very important. What is the next part now? Let's run running containers on Kubernetes. We've talked about this in that image, so it's just practically the same thing. Another one is networking now. Okay, networking, there are 4 stages of networking in Kubernetes. We have container to container communication. Another stage we have in Kubernetes is port to port communication. And another one we have is port to service communication. And the last one is external to service communication. Container to container communication is There's that image. This pod can talk to this pod here due to the fact of due to the reason of pod-to-pod communication. Another one is pod-to-service communication. An example of a service communication is this Kubernetes object here. Name Epka set. Did I do service? I think I have one service file here. Service. Okay, it is here. Service. Yeah, this is a service communication now. Your service communication is the networking aspect of your communication. In terms of if you have a pod you deploy, there's no how you can communicate with that pod without service. That service it that connects your pod to the external world. Without your services, you cannot access your Kubernetes pod. Like now, when I deploy this pod here, I cannot access it without the service. So I have to deploy another YAML file that is called service for me to be able to access that container. So I'm going to do an example of, I'm going to talk about, before I talk about service very well, I will do example of deployments. In production, they don't use pod because in pod does not have the ability to do replication. So they don't really use pod in production. So what they use is deployment. And this is an example of a deployment YAML file. I think I have one here. Demo 3. Okay, post sample. Yeah, this is an example of a deployment file. So here we have API version. If you can see now, your deployment YAML file is different from your pod. It is clearly stated here. The kind of the file is called deployment. Then the metadata, which is the label about your deployment, is telling us that this app is an Nginx app. The name is Nginx. You can actually specify if it's a namespace, because in an organization, you can have different type of namespace. You can have the production, you can have the staging, and you can have the development. So it is in this metadata you are going to state it. Then the spec, it is where you are stating, okay, I want 3 replicas. So every time, now let me deploy, every time I deploy this YAML file, I'm going to have this Nginx pod, like 3 of it. So let's try it out and see if we are actually going to have 3 replicas. If you notice this one, the pod, we're only able to have only 1 replica. So let's try this deployment and let's see how the replica set of deployment work. Within this, I click VIM. Where is that? Replica sets. So we copy this deployment file. So our name is this, our image is that, and this is this. So after we create our YAML file, we do kubectl apply -f. Let's just use the create. Let's use the create command to see if our this thing is good. If there's no issue, it should tell us. Oh, I didn't put the F. So we've created it. Then we'll have to apply this thing. The YAML file is correct. Warning, restore deployment engineers is missing the kubectl Kubernetes last apply configuration method, which is required by Kubernetes. kubectl apply should only be used on resources created declaratively by this thing. Wow. Really? kubectl gets what? Let's see if not sure. It has actually created the pod. You can see 36 seconds ago. These are the three that we created, the three pod. So we were, without doing it one by one, we're able to create three. If you change your YAML file, maybe I change the replicas to, let's change the replicas to maybe 5. Let's change it to 5. We see that 5 of these pod have been deployed immediately. So we have to do kubectl apply again. Then you get your pod. You can see here now, if you are to count the number of this thing now, we have 1, 2, 3, 4, 5. So that is how deployment works. It works with replica, and the replica cells work with controller. I don't know if you have a question. You can kindly ask before I proceed. Okay, Mr. Biela.
So sorry. My question is, I understand like maybe I've still not got to the concept fully yet, but I understand like the worker nodes are like replicated across all of them, right? So do we have one instance of control plane running, or it's also replicated in case that one itself goes down? I hope it's a sensible question.
No, all questions are sensible. Well, I'm trying to get your what you're curious about. Are you curious about the worker node or the are you curious about the worker node or the replication of the pod itself? Mr. Biela, I'm waiting for you.
I think he has left the call.
He has left the call.
Wow.
Okay. Does anyone else
maybe he
any other
wanted
question? Okay, what do you
I said maybe he wanted to know if we can replicate the control plane. So with that, I'm just
are
perceiving
trying to
probably that's
imagine
the
his question?
question. Yeah, exactly.
If it's that is asking of, I don't think so. You can have different control plane. You can have different control plane and also different worker node because of high availability. If one control plane is down, we want the other ones to be available.
Okay.
But it's not yet to answer the question. So, to be sure we answer this question. Does anyone have another question? So moving on to the next this thing in terms of networking. So another this thing I would like to speak on is networking aspects. Is we have third-party networking platforms such as Weave, Selenium, and Project Calico. All of these, they are necessary to help us to organize our IP addresses and the IP table use. So we use anything like the use of core DNS and this thing. Weave and Selenium are in charge of it. So if you want to, because in Kubernetes, one thing that makes Kubernetes is that it has the ability to extend its capability by using other features. So all of these Wiz and Selenium, they are networking platform that you can actually integrate with Kubernetes to help us to manage our domain name services and other add-ons.
Biola is back.
Oh,
Yeah, sorry. I think I just lost connection all of a sudden. I
all
didn't
right.
even hear the answer to the question. Sorry.
We were trying to get your question, so you should help us by helping us recap it.
Okay. So you explained like there's the control plane and then you have the worker node, right?
Yes, sir.
So my point is that control plane replicated? I might be wrong, but I felt the worker nodes were more like the ones replicated, or is it the entire thing that's replicated with every node?
Okay, your control plane can be replicated if you choose to, but it's not a necessity. The instances when you replicate a control plane is maybe you are working, you are trying to make high availability a priority. Then you are putting one control plane in a particular availability zone. Then you are putting the other one in a second availability zone. Does that answer your question?
Okay, yeah. So in that case, you now define it in that your same deployment file. Like that's where you define it
Yes.
also.
Yes.
Okay. If not, you just ignore it.
Yes, it would use the default configuration.
Yeah, thanks a lot.
All right. So the next aspect I'm going to, okay, let me speak about one more Kubernetes object. Which one will I pick? Replica set. Replica set is almost same thing with your deployment, but it's different. In the past, people use replica sets, but right now deployment is what they use because what one ability of the replica set has is to give you replicas. Why deployments will do better than that? So people don't really use replica set, but it's a Kubernetes object. So mostly they use deployments as your Kubernetes object to deploy your pod. Then the next one is scheduling. I think we discussed about scheduling when we talked about featuring and scoring. When we talk about pod affinity, pod anti-affinity, then we talked about toleration, and we talk about we talk about toleration and tint. So those are all of those. They work with your conditions. So we are going to probably check some YAML files because this mini cluster is just one. So it's just one cluster, just one control plane. It doesn't have worker node. We are just using it to test simple plot deployment and everything. So it doesn't really have ability. We don't have the freedom of choosing, okay, go to this worker node, go to the next worker node. It's not available. We are just using it to test how to write YAML file and see how our YAML file works. These are the pods we deploy. So we can actually go to our deployment file and reduce our replicas to maybe let's reduce it to 1. You make you click 1. Whatever pod you have, we turn to 1 immediately. You sit here, apply. Yeah, apply. Then you do get. You can see this thing is already terminating. Those other 5, they are terminating the only one. So Kubernetes is so smart and it works automatically. So that's all about scheduling. The knowledge gap, you can do that on your own. So working with Kubernetes, we are still going to talk about the objects maybe on Saturday or Sunday. I don't know when we should put the next class. So for today, I don't know if I've done justice to Kubernetes for